Okay, yeah. It's William Yin from BM Homes, and my presentation will focus on the current wind turbine in Edmonton. It's a commercial building. Next slide, please. The wind turbine is take a big chunk of the renewable energy. As you can see, in 2020, the solar PV is 45% global wide, and the wind turbine is 38%, which is almost the same equivalent to the solar PV. Uh, in Alberta, it's a rich wind province. We have more than 30% compared to the whole Canada. And however, the wind for the macro wind turbine is really, really small. We in Alberta, we only have 0.1%. The reason for that is in the small turbine, it really depends on the wind speed, and so it's less than 6 meters per second. It's hard to generate some power. But in the recent years, the micro turbine technology is really improved a lot. And but we still, it's a blank area in the urban environment. The reason for that, the high rise building and those things only the speed is much lower than the rural area, and the wind is turbulent and it's hard to catch. We believe our project is the first one in Alberta, and we test run that one. Thanks Sarah to give us funding for that. Although it's a small project, but it's really have big potential. And why? Solar PV is quite used in the recent years in the urban environment. But as we all know, the solar PV had their own disadvantage. Like, of course, at night, you cannot get any sunshine. In the winter, the solar PV workings not very well, only about 20% of the capacity for the compared to the summer. And the wind turbine is a good candidate to just fill that gap. Uh, at night, the wind is stronger. In the winter, the wind is blowing sometimes crazy, yeah. And we just want to try to get an alternative way to get our renewable energy in the winter and night. And like you can see, all the renewable is capacity based on the peak hour. If the winter we don't have any alternative solution, the grid when the electricity go to the grid, it still need to meet the peak demand, right? If the wind can take some of the capacity, that will be huge potential for that. And yeah, that's but the wind also has some barrier or constraint for that. Like I said, the low wind speed in the urban environmental and some structure safety and noisy pollution, those things, and we need to accommodate that. Basically, this is the first run, and we will see the answer this winter, see it's good or not. Next slide, please. Okay, here is our project. It just recently installed. We got 4 of the wind turbine on the roof. It's a commercial building and a single story. 3 wind turbine is sitting on the wood stand like you saw. The fourth one is hard to see. It's on the corner, and it's a stainless steel one. The 3 wood stand one now it's working very well with the solar PV on the back. If you can see, as I mentioned before, we want to test run the solar PV with the wind turbine. Why? We want to know the when the solar PV is not that good. with the capacity if the wind turbine can take at least some of the energy consumption. Next slide, please. This is the air photo for the layout. The 3 or 4 turbines only can 3 turbines on the left and the solar PV on the right. A little bit explanation for the solar PV because although it's together, but we group them on the 3 sets. Each set combined to 1 wind turbine. That way we can measure each different turbine's size and models, see which one is better fit for the urban environmental in Edmonton. We have some data in the past from the federal, but we also have installed our own weather station on the roof to catch on the exactly date there. Next slide, please. This is the control room we are setting up to. On the right, those 3 red one is the controller. Each controller control 1 of the turbine. And on the top, it's a black wire. I know it's not a great picture. It's basically catch the data from the controller to the left. If you can see a black box, that's the computer. Above that computer, we have a converter to get the signal and goes to computer. Down of the computer, we have a screen to see the actual date. Actually, this one is online now. If you want, I can share the data. It's a on-time data. And at the bottom, you can see 2 battery. The third one is far behind, so you cannot see very well. The green one is the fuse. I think, yeah, that's pretty much the setup for the control room. Next slide, please. This is the single line diagram for the whole control portion. As we said, we run the test run, we need to collect all the data to see if this one is feasible or not. And from the right, again, we have 3 turbines with 3 solar PV. So basically 3 sets of the setup. And each setup get 1 battery to store the power, and we have also have a switch with the inverter. That one can go through the grid. Next slide, please. This is a report in August, and on the right again, the red one, we can see the temperature of the current temperature. The blue one is the wind speed meter per second. And the orange one is the solar radiation data. The fourth one will be the cloud. As I said, it's a weather station on the rooftop as well. So that's the reason we can able to get those real data. And on the left, you can see it's a summer. The speed is only 6 meters per second. The turbine is not working very well, but still we get some power. And we set up 4 wind turbine, but the stainless steel one is not working very well. We're still fixing that one. So that's the reason you only can see 3 active controller on the upper left. Next slide, please. And the estimate generate power and the voltage and this one here. Again, this one driven by the computer, and we can see the real data. And hopefully we can have something 1 year around and get more realistic see we can how to utilize those wind turbine. Next slide, please. For this kind of setup, urban is the most important, interesting point, and we can also use it for the local area, like the park, the shelter, those kind of thing, remote area. So we have some potential use in the future. See if the test run runs good, and we can have some future jobs.